Hey guys, as we saw yesterday that a Windows Server pattern, extending the Windows Server pattern. Now today we are going to see about that extend Linux Server pattern. So that is this Linux Server pattern also like the same only like Windows. We have done the Windows Server pattern earlier, right? Like that only we are going to do. Some modifications will be new. So the cloud dimension is interested in tracking the run level value from the Linux servers. Cloud dimensions want to build or extend the Linux server pattern to accomplish this task. Those kind of tasks are a new Linux server attribute, new pattern steps, and also that extension section pattern steps. So those kind of things we are going to see. So now I just to go to the Linux server. Let me go to the Linux server. Once we enter into this page, we can select this already discovered IP address. This is this one, 234.24. Let's select this one. In previous class, we have uh, created the form design, right? That form field. So let's do the same in here also. Now can right click form layout. It's getting too slow. Now let's name this as field types. Run level. So now let this string field as a run level and add this, and again we can keep this under the asset field and save this one. So let's close this. So once this can be loaded, you can see this run level string field. Now I can create the pattern, new pattern steps. Let's navigate to the Unix under CA classification. So let's go to the Unix. Now let me select this Linux server, Linux classification. Here you can see this trigger props. The horizontal discovery probe. Let me check the pattern, how the which pattern they have used. They have used this Linux server pattern, right? So when a CA is classified as a Linux server, the horizontal discovery probe, horizontal path probe uses the Linux server pattern to identify the CA through a series of pattern steps. So we can extend this pattern to include a step to capture the run level information and populate a run level field. So let's go to the discovery patterns. Here is our discovery pattern. Open Linux server. This is our here you can see, as we see in the previous video, that CMDB Windows Server, you can see that, right? Now in this Linux server, you can see those kind of basic pattern tracker files, those kind of tabs, and also identification section, extension section, those kind of things are there. So the extension section is used to add the identification section steps without modifying the baseline pattern steps. During the ServiceNow version updates, baseline patterns could be overridden. Extension sections are stored in a shared library, which is not overwritten during the ServiceNow upgrades. Now click New for in the extension section. So we already customized it. They have extended these things. We additionally provided the third custom steps for this. So the order is auto-populated. Now we can name this as a custom steps Linux and click done. Once we created, you can click this one. You can see this extension sections pattern configuration. So let's enable the debug mode. Here, as we already see this, we can select this Windows mid server, and we should need to provide the Linux IP address. For that, we already discovered on discovery schedule. Let me open that one, or else in the this is the IP address we have. 98.51.234.24. This is a Linux server IP address, which we discovered this one using the Linux schedule discovery. So let me use that same one. You just copy and paste it in here. Let me replace the if and two dot. So now you can connect this. Let this debug mode can be processed. Now I enable the debug mode. Let's rename this steps. So I just make the name as parse run level. Click OK. Now I can provide this operation as a parse command output. So this is a parse command output. I just provide who minus, then click this run command to view the raw data. What is the raw data which is given? That is loaded. Command has been loaded. You can see this delimited text. Now I can provide the run level using the table. We can able to select this table. Then you can make this as a run level info, like that. You can provide this table name. Then in the variable name, we can provide the field name, field backend name. So here is our field name. You can copy this backend name of the run level. So once we select this, you can verify this one. Now we need to define the delimiters and the position values. Before we make that, we should need to know what is the W who minus R. That is called the run level is one of the modes that Unix based operating system runs in. In the Linux kernel, there are 7 run levels starting from 0 to 6. In this step, the who minus R command is used to collect the run level from a Linux server and store it in a table variable. This is a table variable called run level underscore info. And now we can provide the position. So here is a delimiters. Let's select this one, and we can provide the space as a delimiter. Click done. The position could be 2. So once we select the space as a delimiter, that the second position, the value has been selected. So this value only populating. So if I select a 3, you can able to see this as a selected. So if you select 4, this one should need to select. Like this, the delimiter can be vary. This is the space, this is the position. So we need this value only, 3 value only. So I just select the 3 position. Oh, sorry, 2, because this is a second position. So 3 is a second position. So I want this 3 value only. So I selected that one. We can, let's test this one. Now we had saved this Linux server extension pattern. Let's go back. So now we are uh, going to that virtual machine and check how the discovery getting reflected. The custom steps Linux should need to reflect. So let's see now. Now we are in the virtual machine, which is the mid server host. Now let's go to the files. Let's select this one. We can go to the mid server install folder. Select this agent folder. Click continue. You can find this work folder. Here you can see this NDL directory. So cache discovery patterns are stored on the mid servers in the NDL directory. It is important to verify the mid server is using the latest pattern version. Alternatively, for the training environment, it might be necessary to reboot the mid server to force the extension section pattern changes to take the place immediately on the mid server. So these things are stored in the NDL directory. If you type Linux based directories, you can able to see this custom steps Linux. So we have configured this one. So this has been stored in here, right? Discovery status got completed. Now you can select this discovery log. Let's see the exploration has been reflected. So here you can see that horizontal discovery probe has been populated. Let's check this one. Exploring CA pattern name Linux server. So let's click this one. So we had created the parse run level, right? This one custom steps level. This one. Let's select this one. This one only we have configured. So you can see this executing SSH command who minus R, then run level, those kind of things you can able to track it, right? So the currently the parse run level pattern step has only written the value to a variable called run level. Let's see. Close this. Let's open this CA. Now let's close this one. So now I just come to this CA. Again, let's create this time zone. Let me, this is a run level which we have already created. The value won't be upgrade. The three should need to update. But after we do the further extension, then only the values should need to update. So let's create another field called the time zone. Okay, can put it under level run level. Close this one. Now you can again go to that extension step. Go to the Linux pattern, discovery, and discovery pattern. You have the Linux pattern, Linux server. So here is our Linux server pattern. We have created this one, right? Custom Linux, custom steps Linux. Let's open this one. So let's create the second step. So in this second step, let me name it as sparse time zone and enter it. Here again we can parse, we can select this parse command output, which we have already done earlier. Again, we can provide that timing, right? So before providing this information, let's enable the debug mode. The IP address could be Linux IP address. Let's connect this. Debug mode has been enabled now. Let's fill this command details. Let me make time and run this command. Wait for some time. I think we need to select as date. Let it be complete and then check. So let's select, let's make date and run it. Let's wait for some time. Now in the output you can see the date. So now let's select this table as usual we have done in the previous lecture. Time zone. So the backend value will be this one. Sorry, let me load this. Time zone. So this is a time zone. So we are going to select. We need to select this kind of EST. The time zone will be EDT. EST, EDT. Those any of the output we can able to get. So let's select that. For that, what should we need to do? That is the position number 1, 2, 3, 4, 5. So fifth position. Let's do that. The delimiter will be space, click plus, and done. Then the position will be 1, 2, 3, 4, 5. Fifth position. So the time zone has been selected. Now you can test this. So due to some issues, the test operation has not run, but we can further create the third step. Let's create the third step. Let me do one thing. Let's see the third step in tomorrow. So this video gonna be lengthy one. So let's see you on the next video.